Hi there! For today's video, we are going to talk about sets and problems involving sets. So, prepare yourselves and let's get started right away into the video. So, what is a well-defined set? In mathematics, set is a well-defined group or collections of objects that share common characteristics. The objects contained in the set are called elements. A set can be named using capital letters like A, B, C, D up to Z. And we use braces to group the elements of set and separated by commas. If a set contains many elements, we often use three dots called the ellipses. Take note that in listing the elements of the set, each distinct element is listed only once and the order of the element does not matter.
Now let's have examples of a well-defined set. First, the set of primary colors. So, the set M has the elements red, yellow, and blue. Once again, remember that this M here can be substituted by any letter, and also let us use the braces all the time to indicate that these are the elements of the set. Okay, so next, we have the set of multiples of 5. So Y, the set Y has the elements 5, 10, 15, and so on, ellipses, meaning to say that this ellipsis goes on. So, it is a well-defined set because 5, these numbers is really a multiples of 5. Okay? So next, the set of all even numbers. So we have here the set E has the elements 2, 4, 6, and so on. And the set of the letter in the word arrange. So the set O has the elements A, R, N, G, E. So if you remember, we've said earlier that these repeating letters R and A can only be written once. So that is why in the word arrange there are only 1, 2, 3, 4, 5 elements. Okay? So next, let's have the example of not well-defined sets. The set of famous dancers. The set of punctual students in your class, and the set of honest people. So, it is said here that the set given above are not well defined since people will have different point of views on famous dancers, punctual students, and honest people compared to the examples earlier that of a well-defined set. So, we really have an answer of these sets, right? So that's it.
Now here are other important terms to remember when we talk about sets. The universal set, the subset, the null set, and the cardinality of sets. Now let's talk about universal set. The universal set U is the set that contains all objects under consideration. Let us take a look at some examples of this universal set.
Set U contains the set of whole numbers. So, we have here the set U. The universal set U contains the set of whole numbers. So, this is a universal set because it started from 1 and then up to infinity. So, it is because we use here the ellipsis. And once again, a whole number are a positive integers starting from 1. So this is really a well-defined set. Next, we have set U contains the set of all letters of the English alphabet. So we have here set U has the elements A up to Z. So there are 26 elements here. It is complete. That is why it is called a universal set U. And then we have third example. Set U contains the set of days of the week. So we know that there are 7 days in a week, right? So the universal set U has the elements Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, and Saturday, which are all in all, there are 7 elements. So it is complete. So that is why this set U here is a universal set.
Next, we have the subset. Given any two sets A and B, if any elements of A is also an element in B, then A is a subset of B. Take note that every set is a subset of itself, and an empty set is a subset of every set. Let's take a look at some examples.
Set O has the elements red, blue, yellow. So the possible subsets of O are, if there are 3 elements, the possible subsets are red, blue, and yellow. If they require 2 elements, so we can choose from among the 3. So we can write red and blue, red and yellow, or blue and yellow. So these are the possible subsets of O when there are 2 elements. If 1 element is considered, the possible subsets of O are red, blue, and yellow. And if there is 0 element, it will be an empty bracket or this symbol. Okay, so another example. Let's take a look at this set. The set S has the elements 3, 6, 9, 12. So the possible subsets of set S are, if there are 4 elements once again, we will write all the elements that is included, which is 3, 6, 9, and 12. And if there are 3 elements, we can choose among the 4 elements. So we can write either 3, 6, 9, 3, 6, 12, 3, 9, 12, or 6, 9, 12. So these are the possible subsets if there are 3 elements considered. Next, if 2 elements are considered, we can write the elements are 3 and 6, 3 and 9, 3 and 12, 6 and 9, 6 and 12, or 9 and 12. So these are the possible subsets of set S when there are 2 elements. If there is only 1 element, we can write 3, 6, 9, 12 in each bracket. And then if there is a 0 element, we can write an empty bracket here or this symbol. And these are the possible subsets of set.
The next term is the null set. Do you have any idea about it? A set with no element is called an empty set or a null set. The symbol of a null set is T. Some examples of a null set are the following.
Set T is the set of counting numbers between 1 and 2. So it is a null set because there is no counting number between 1 and 2. 1 and 2 are 2 consecutive counting numbers. So if there is a number between here, it is a decimal or a non-integral number. So that is why our set P is a null set, an empty braces or using this symbol. Another example. Set I is the set of months with 35 days. Do we have a month having 35 days? There is none, right? So, it is a null set. Another. Set B is the set of flying castles. These flying castles does not exist in reality. That is why it is an empty set. And set E is the set of crying trees. So are there crying trees? There is none, right, in this reality. So we can only see crying trees on our imagination, on fantasy, like that. So that is why the set E is an empty set.
Then, we also have the cardinality of sets. The cardinal number of set A, denoted by N, open parenthesis A, close parenthesis, is the number of elements in set A. For example,
set B is the set of vowels in the English alphabet. So, when we say the cardinality of sets, first let us write all the vowels in the English alphabet. So, the set B has the elements A, E, I, O, and U. So, when we say cardinality of numbers, once again, these are the number of elements in a set. So, our answer will be 5. It is because there is 1, 2, 3, 4, 5 elements in set B. Next, set M is the set of odd numbers between 1 and 3. So, what are the odd numbers between 1 and 3? So, our set M is an empty set or a null set. It is because there is no odd numbers between 1 and 3. So, a number between 1 and 3 is 2. It is not an odd number, it is an even number. That is why this is an empty set. So, the answer will be 0. That is the cardinality of set M. Next, example number 3. Set E is the set of letters in the word survivor. So again, we can write the solution. We can write the set E has the elements S, U, R, V, I, O. Once again, in writing the elements of this word, we will only write 1. So our answer here, the cardinality of set E is equal to 6, which is 1, 2, 3, 4, 5, 6. So that is true.
now let's talk about the operation of sets. There are 3 operations of sets, namely the union of sets, the intersection of sets, and the difference of 2 sets. The union of set A and B, written as, is the set of elements that are members of A, or members of B, or members of both A and B. Let's take a look at some examples.
If A has the elements 1, 2, 3, and B has the elements 1, 2, 4, 5, 6, then A union B has the elements 1, 2, 3, 4, 5, 6. So, these are the elements that are present in both set A and set B. So, we will only write once. Once again, there are, in every set there is 1, 2, 3. The 3 here is included because that is union. Next, if A has the elements A, B, C, D, E, and B has the elements A, E, I, O, U, so then A union B has the elements A, B, C, D, E, I, O, U. Again, we will just copy all the elements of A and B, and then if these letters are repeated, we will only write them once. Okay? So, next, example number 3. If set A has the elements Monday, Tuesday, Wednesday, Thursday, and Friday, and set B has the elements Saturday and Sunday, then A union B has the elements Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. So, they are just Tuesday. So we just combine the elements that are present in A and in B. So that is the concept of union of sets.
Next operation, we have the intersection of sets. The intersection of sets A and B, written as, is the set of elements common to both set A and set B. For example,
if A has the elements 1, 2, 3, and B has the elements 1, 2, 4, 5, and 6, then A intersection B has the elements 1 and 2. So if you observe here, we just copied 1 and 2. It is because these two numbers, 1 and 2, are the only elements that are present in both sets. Let's take a look at another example. If set A has the elements A, B, C, D, E, and B has the elements A, E, I, O, U, then what do you think is the answer? Okay, so A union A intersection B has the elements A and E only, because these are the only numbers that are present in both sets, A and E. That is the answer. For the third example, if A has the elements Monday, Tuesday, Wednesday, Thursday, and Friday, and B has the elements Saturday and Sunday, so what do you think is the intersection of these two sets? So the answer is the intersection of A and B is an empty set or a null set. It is because there is no element that are present in both set A and set B. That is why it is a null set. And that is the concept of intersection of sets.
finally, we have the difference of two sets. The difference of set A and B, written as, is the set of elements in A that are not in B, or vice versa. If we say the difference of set B and A, it will be the set of elements that are in B and are not in A. Let's take a look at some examples.
If set A has the elements 1, 2, 3, and set B has the elements 1, 2, 4, 5, 6, then the difference of A and B, or written as A minus B, is only 3, while B minus A is 4, 5, 6. That is because, okay, let's take a look at this first one, A minus B. So, only the number 3 is present in A that are not in B. While in B minus A, 4, 5, 6 are the numbers that are present in B and are not in A. So that is 1. Another, if A has the elements A, B, C, D, E, and B has the elements A, E, I, O, U, then A minus B is B, C, D. A minus B is B, C, D. So B, C, D is not present in set B. That is why it is the answer in here. While B minus A is I, O, U. So we can see here that I, O, U is only present in B and not in A. Next, if A has the elements Monday, Tuesday, Wednesday, Thursday, Friday, and set B has the elements Saturday and Sunday, so then A minus B is Monday, Tuesday, Wednesday, Thursday, Friday. So all these elements in A is not present in B. That is why we write them all in here. And then, while B minus A, Saturday and Sunday, again, Saturday and Sunday are all not present in set A.
Now let's take a look on how to solve problems involving sets. In solving problems involving sets, we can encounter the term Venn diagram. Do you know what Venn diagram is?
Venn diagram is a principal way of showing sets diagrammatically. This method consists primarily of entering elements of a set into a circle or circles. It can be used to solve word problems involving union and intersection of sets. Now let us take a look on how Venn diagrams are used in sets. First, let's see this first picture. This picture denotes A intersection B. So the only shaded region is the region here in the center, which is common to both A and B. Next, we have A union B. So the shaded region are both the circles of A and B. And difference of A minus B. The shaded region here is only the part wherein A is, the shaded region here is the part of A. So all the parts of B is not shaded in here. Next, B union C. So here we have three circles, a Venn diagram composed of three circles A, B, C. So the only shaded region are the circles of B and C. So that is B union C. While if it is all shaded, A union B union C. So that's it.
In solving set operations using Venn diagram, these are the steps to be followed.
Step 1. Determine what is given and what are being asked. Step 2. Illustrate using Venn diagram. Step 3. Determine what operations to be used. And step 4. Use these operations. And step 5. Answer the questions being asked. So all in all, there are 5 steps in solving set operations using Venn diagram. Let's have an example. Let A and B be two finite sets such that n, the cardinality of A, is equal to 20 and the number of elements in B is 28 and the number of elements of A union B is 36. So find the number of elements of A intersection B. So our first step is to determine what are the given and what is being asked. So our given is the number of elements in A is 20, number of elements in B is 28, and number of elements in A union B is 36. So what is being asked? Find the number of elements of A intersection B. Number of elements of A intersection B. So step 2, illustrate using the Venn diagram if possible. So is it possible? Yes, of course. So our goal is to find the number of elements of A intersection B. So we have here a universal set, and then set A and set B. We combine them both to find what is in the center, which is the A intersection B. So this is the slide, this is the shaded region. Okay, so next step. Determine what operations to be used. So, using the formula, and the number of elements of A union B is equal to the number of elements of A plus the number of elements of B minus the number of elements of A intersection B. So this formula is a formula that is used for finding the cardinality of sets. So we have here, we revise this formula. We get this formula based from this main formula here. So our intersection here, we move it on the left side, this one. We move it on the left side, it becomes this one. And this number of elements of A union B, move it to the right side, and that is it. So, our N number of elements of A intersection B is, so our number of elements of A is 20, that is why we wrote 20 here. Number of elements in B is 28, and number of elements in A union B is 36. So we further simplify. So we've got the number of elements of A intersection B is 12. Now step 4 is use these operations. So let's see. So that is it.
So where did we get that 8 and 16? First, let's have the 8. The 8 is the difference of A minus B. All in all, we have 20 elements in A, but 12 of it is also an element of B. So, we have to subtract 20 from 12 to get 8. Same with 16. It is the difference of B and A. So all in all, we have 28 elements in set B, but 12 of it is also an element in set A. Therefore, we must subtract 12 from 28, which will give us an answer of 16.
Then step 5 is to answer the question being asked. So the question is find the number of elements of A intersection B, which is 12. And that is the answer.
Another example is presented in our Google slide. That's it for now, and thank you for watching this video. Till next time, bye!